A very warm welcome, my dear students. In today's video, I will be solving paper 2 0625 variant 1 October-November 2025. So we'll start with question number 1. A student determines the diameter of a metal ball, which apparatus is needed to get an accurate measurement. So let's look at what all options are given to us. There's a ruler, there's a protector, there's a set square, and there are rectangular blocks. See, we have to have a little bit of idea about the fact that a ruler is used to measure length only, right? A protector can help you measure the angle. But now when you talk about a ruler will help us measure the length. So that is what relates to the diameter. That's one thing. A protector has no use over here because it can only help us measure the angle. And while measuring the diameter of the metal ball, the angle is not required. So protector is out of question, therefore option A and option C are out of question. Now comes in the option B, a ruler only. A ruler alone cannot help you find out the diameter of a metal ball. Therefore, the correct answer would be D, a ruler and two rectangular blocks. Now how does this ruler and the two rectangular blocks work? For that, just look at here in this diagram. If I place the metal ball in between the two rectangular blocks, right, and I mark the x1 point where the metal block begins, like one of the metal block ends, and I mark x2 where the metal ball ends. So I have x1 where the metal ball begins and x2 where the metal ball ends. If I take these 2 points, or if I take these two endpoints and I subtract this, if I do x2 minus x1, then I'll get the diameter of the ball. That's how I can find out the diameter of the metal ball. I hope you understood. Let's look at the next one. An athlete runs at a speed of 8 meters per second for 10 seconds and then at a speed of 6 meters per second for 12 seconds. Which calculation gives the average speed of the athlete in meters per second? The average speed is the total distance by the total time. So, to find out the total distance, first let's look at the part that how much does the athlete run in the first 10 seconds, which would be 8 times 10 because the distance is given by speed multiplied by 10. So, 8 meters per second multiplied by 10 gives me the distance covered by the athlete in the first 10 seconds. Then, for the next 12 seconds, the distance covered is 6 times 12. Therefore, the total distance becomes 8 times 10 plus 6 times 12 and the total time becomes 10 plus 12, that's a 22. And hence, over here, if I look at the options, I can say that option B is correct. Now, let's go in for question number 3. A piece of paper torn out of an exercise book is shown. Describes how a massive object affects the space around it, including the size and the direction of the force it would exert on other objects placed in that space. What is being described? Okay, let's have a look at the options once. It's the gravitational charge, the gravitational field, the gravitational mass, or the gravitational potential energy. See, there are two things to look in here in the question that's given to us. Firstly, they are saying it's a massive object. Secondly, it is affecting the space around it. When anything inside the space is affected, it is always a field. And it's a gravitational field because it is massive. Okay, so they have also referred to the force that it would exert on any object that would enter into its field. So the correct answer here is gravitational field, simply because they are talking about the effects that are present in the space around the mass. I hope that's clear. Let's go to question number 4. The diagram shows one liquid floating on the top of another liquid. Which statement explains why liquid P floats on the top of liquid Q? See, we already know that if one is floating above and one is below, that means the density of the one at the top is probably less because the more dense liquids would obviously be at the bottom. So density of P is less than the density of Q. Density is nothing but mass per unit volume. So I can say that the mass of P by the volume of P is less than the mass of Q by the volume of Q because the density is less. Now, let us try and relate it to the options. In the first option, it says the mass of the liquid Q is greater than the mass of liquid P. Sorry, we cannot say that because this part does not talk about the volume. The ratio of mass and volume of Q is greater than the ratio of mass by volume of P. So A is wrong. Let's look at option B. The mass of 1 centimeter cube of liquid Q is greater than the mass of 1 centimeter cube of liquid P. So over here, if I take the volume of P and Q as 1 centimeter cube, then definitely I can say that the mass of P is less than the mass of Q, or the mass of Q is greater than the mass of P. So B option is the correct option. If you want, you can look at the other options also, but B option is the only one that fixes the volume as 1 centimeter cube and then relates the masses, and that's the correct way to answer it. So option B is the correct answer. Now for question 5, a spring has a spring constant K. What is the possible unit for K? Now we know, as per Hooke's law, force is K times E, or I can say force is the spring constant times the extension. If I rearrange this equation, I'll get the spring constant K as force by extension. Now force is measured in newtons, extension is measured in meters, therefore the unit for spring constant has to be Newton per meter, and hence option C is the only correct answer. Now for question 6, which statement about the moment of force is not correct? See, moment of force is nothing but it is force times the perpendicular distance between the force and the pivot point. So keeping this definition in mind, let's look at all the options. In option A, it says, if an object is balanced about a pivot, the resultant moment of the object must be 0, which is true. So it's not our answer. Then look at option B. The moment of force is a measure of its turning effect. That is also correct. Option C. The moment of force about a point is equal to the force times the perpendicular distance from the point, which is also correct. Lastly, so obviously if A, B, C, A are the correct statements, then option D is our answer. But let's look at it once again. So the moment of force about a point increases when the perpendicular distance of the force from the point decreases. This statement is wrong because moment of force is force times distance. If I would decrease the distance, then the moment of force should also decrease. Hence, the incorrect statement about moment of force is option D. Now, for question 7, the momentum of a car changes from 10,000 kg meter per second to 15,000 kg meter per second in a time of 8 seconds. What is the resultant force acting on the car? See, the force is change in momentum by time. This is as per the Newton's second law. We know that force is change in momentum by time. So the change in momentum here would be the final momentum minus the initial momentum, which is 15,000 minus 10,000, and the time in which this takes place is 8. So the calculation is pretty straightforward. It is 5,000 divided by 8. When you calculate this comes out to be 625 newtons, which is approximately same as 630 newtons if you round it off. Hence, option A is the correct answer. Let's look at question 8. A machine is very efficient. What does this mean? See, efficient means that the useful power output or useful energy is much more than the energy that is wasted. That's all that we can conclude from here. So it produces a large amount of power. We do not know how much amount of power it is going to produce, but we know that the output energy is more than the energy that's wasted. So it uses very little energy. That also what is something which we do not know. If you look at option C, it says it wastes very little energy. That is correct because I already told you that the useful energy has to be greater than the energy lost. So option C works well. It works very quickly. Again, that is not the correct answer because we do not know how much time it takes to work it, right? We can only say that my useful energy is larger in comparison to the energy that's lost. So option C is the correct answer for question 8. Now let us move on to question 9. For question 9, it says diagram 1 shows a conical flask containing water. Diagram 2 shows a beaker with the same base area as the flask and containing water of the same depth d. Which statement is correct? If you look at the options are talking about pressure basically. So we know that the pressure of a liquid is directly proportional to the depth. Now since the depth for both of these is same, they both are at the same depth d, therefore the pressure at the 2 points has to be equal irrespective of the shape and size, because pressure of a liquid only depends on the depth of the fluid. Since the depth is same, therefore the pressure for both of these has to be same, and hence the option A is the correct answer. For question 10, a flask with a tight fitting stopper contains a gas, and the gas and the flask are initially at room temperature. The gas and the flask are cooled, which means that the temperature has been reduced. Which row describes the average speed of the gas particles and the pressure of the gas as the temperature decreases? See, the kinetic energy of the particles is directly proportional to the temperature. So if we lower the temperature, then the kinetic energy is reduced. And since kinetic energy is the one that decides the speed, if the kinetic energy is less, then the speed also has to be less. So the average speed of the gas particles has to reduce. Secondly, if you talk about the pressure of a gas, the pressure of a gas is also directly proportional to the temperature, because when we reduce the temperature, that time the particles, they have lesser amount of energy, so they collide less often, or you could say that the collision frequency decreases, and hence the pressure would also decrease. Therefore, option A is the correct answer. The average speed has to decrease and the pressure of the gas also has to decrease. If you understood all these 10 questions, then watch out for my next video, which would contain the remaining part of the paper. Also, do not forget to subscribe to my channel for more learning.